Let's talk about our power grid. This is the basic schematic. You've got a power station where the electricity is generated, and the power station can be located anywhere, but it generally isn't located in the heart of a city, so it's usually some distance from the cities which it serves. And so, consequently, the electricity has to be sent over power lines over some long distance. And when it gets to the city, it is diverted to various substations. And then from the substations, it goes to our homes and businesses. Obviously, cities use a lot of electricity, a lot of energy. And the formula that's important here is P equals IV. The power station has to have the appropriate power, that is to say, it has to provide so many joules every second to meet the city's needs. So this has to be quite large. And that means your current or your voltage or both have to be large. The question is, which one do you want to be large? Well, let's look further into this. With our power grid, we send the electricity over power lines. And by definition, these power lines are going to be resistors because they have resistance. And that means there are going to be thermal losses. And the formula for that is P equals I squared R. And we want to minimize these thermal losses. That means either minimize the current or the resistance or both. And the answer, by the way, is we do both. If you look at the formula for resistance, first, you make the resistance small by choosing a material with a low resistivity. We generally do this anyway, so that's no big deal. We use appropriate materials to make the resistance small. Unfortunately, the power lines have to stretch, miles, many miles. So L is going to be big. And since L is big, that's going to increase the resistance. Okay? But we can choose power lines with a large gauge, and that will decrease the resistance. So that's what they do. They choose an appropriate material to keep the resistivity small, and they choose large gauges so that the resistance is as small as possible. But more importantly is to make the current small, because the power goes as the current squared. So that means if you double the current, you quadruple the power. If you triple the current, then the power loss is going to increase by a factor of 9. And that's what we're talking about here is power loss. So we want the power loss to be as small as possible, so we want the current to be as small as possible. Well, if the current is small, remember, the power has to be high because the cities consume a lot of electricity every second. So the power has to be high. That means the voltage has to be high, very high, to make up for the small current. And this is why power lines, it always says, for the all around them, it says danger high voltage. But the thing to realize is this formula here is telling us the rate at which the energy is transferred from the power station to, in this case, the substation. Okay? And then you could do it separately for the substation to the individual homes. Okay? But this is telling us the rate at which the energy is transferred along the power lines. And this formula is going to tell us the rate at which thermal energy is generated. In other words, it's telling us the rate of loss.